Hello everyone. In this video, we are going to discuss about the concept sorting algorithms, and the topics I want to cover are algorithm, what is sorting, what are sorting algorithms, what is the classification of these sorting algorithms. Let me start with what is an algorithm. Of course, we have already discussed what is algorithm in the previous lecture. So once again rewind what is an algorithm. An algorithm is a step-by-step process that designed to achieve the best solution for any problem. So what makes a good algorithm? There are two important criteria. One is it solves a problem, and second one is it will solve the problem very efficiently. So these two will make a good algorithm. Let's move on to what is sorting. Sorting is a concept it deeply embedded in lot of things that we do, and it's quite often that we like to arrange things or data in certain order, right? So that order may be in ascending order or in descending order. And why we are using sorting means sometimes to improve the credibility of the data, or to able to search or extract some information quickly out of the data, right? So now we will see some examples where we are using sorting. For example, when we play a card game, even though we are having less number of cards in our hand, we would like to keep our hand of cards sorted, either in increasing order or in decreasing order. So let's say these are our hands of cards which are in unsorted array. Sorry, unsorted numbering. Okay. So which are in unsorted numbering. Now I would like to arrange them. I would like to rearrange them in the increasing order of rank. Then we will get the bunch of cards in sorted order. So let me take the next example. When we go to e-commerce site to order a book, then the site gives these options like price low to high, price high to low, average customer review, and so on. And we can sort the option by using price low to high or price high to low, or using the star rating. So, and the one more example where we are using sorting means when we are searching a word in a dictionary also, we are using the concept called sorting. So these are the simple examples where we are using sorting. So now we will see what is the definition of this sorting. Sorting is arranging the elements in a list or collection in increasing or decreasing order of some property. And the list should be homogeneous. That is, all the elements in the list should be of same type. If the list is having integers, that array should be in integers only. Otherwise, if the array is having only characters, the entire array should be in characters only. So that is what homogeneous. To study sorting algorithms, mostly we use list of integers, and typically we sort the list of integers in increasing order of value. So mostly we are using integers only, so that we will rearrange in increasing order of value only. So let me take an example. For example, if we are having the list of integers as 2, 3, 9, 4, 6, then sorting it in increasing order. So that means rearranging the list in increasing order. So then the list is like this. After rearranging the given list in increasing order, so we will get the values as 2, 3, 4, 6, 9. If sort the given elements in decreasing order, then the list is like 9, 6, 4, 3, 2. Okay. As we see in definition, that we can sort the elements on any property, right? So what if we want to sort this list on the basis of, let's take increasing number of factors. Okay, so the number with lesser number factors is towards the beginning of the list. Okay, so if we are taking increasing number of factors property, then the number with lesser number of factors is at the beginning of the list. If you see, the first number is 2. The 2 is having only two factors. What are those? 1 and 2 itself, right? And 3 is having only two factors. What are those? 1 and 3 itself. And the next number 9, the 9 has got only three factors. Those are 1, 3, 9 itself. And the next number 4, the 4 has got three factors, 1, 2, 4 itself. And the last number 6, the 6 has got four factors, 1, 2, 3, 6 itself. So that is the reason why if we are taking the property increasing order of number of factors, so then the number with lesser number of factors will come towards the beginning of the list. So that's why the rearranging of the above given list is like 2, 3, 9, 4, 6 by considering the number factors. So we may want to sort the list of strings or words in lexicographical order also. So let's see the example on strings. So first we are having the list of words as fork, knife, mouse, screen, key. Now we want to rearrange them by using sorting. So it can be arranged in fork, key, knife, mouse, and the screen. So we may have the text of complex data as well. Next, if a list is sorted in a computer memory as unsorted, for example, if we are having the unsorted list of elements, so then what we need to take? We need to take the linear search to search something in the list, right? So if the list of array, if the list of elements are unsorted, then to search something in this list, we have to take linear search. In linear search, we start at the first element in the list and keep scanning the whole list until we get the element that we are looking for. So in the worst case, when an element will not be there in the list, we will compare it with all the elements in the list. Okay, so if there are n number of elements in the list, then we make n comparisons in the worst case. So as we already discussed about the linear search in the previous lectures, so we know that to search something in the unsorted elements, we are taking the linear search, and the linear search will start at the first element in the list, and it will keep on scanning the whole list until we get the element that we are looking for. So what we need to do, if we are not finding any element in the list, then we need to compare it with all the elements in the list. So we are having the complexity of this linear search as order of n. The worst case, time complexity. So what if we are having the sorted elements of array? So then we need to take the binary search, right? If the list is small and sorted, we can use binary search. And with binary search, if the size of list is equal to n, and it will take log n comparisons to perform a search, that we have already discussed in the previous lecture. Now we'll see what are the sorting algorithms we are having. So we are having the number of sorting algorithms to arrange the elements in particular order, either in increasing or decreasing. So the first one is bubble sort, insertion sort, selection sort, merge sort, quick sort, heap sort, counting sort, radix sort. This is not all. There are more. You can imagine how sorting is important by seeing all the sorting algorithms, right? And let's move on to the classification. We can classify sorting algorithms based on some parameters. The first parameter that we classify upon is time complexity, which is the measure of rate of growth of time taken by an algorithm with respect to input size. And some algorithms will be relatively faster than other, right? So the first parameter that we classify is time complexity. And the second parameter that we use for classification is space complexity or memory usage. Some sorting algorithms are in place and they use constant amount of extra memory to rearrange the elements in the list, which some sorting algorithms like MedSort use extra memory to temporarily store data, and memory usage grows with input size. Okay, so the second parameter is space complexity. And the third parameter that we can use for classification is stability. This one will take some explanation. Suppose we have some chords like this and we want to sort these chords in increasing order of rank, and if you observe this, they have 1 3 of diamond, 1 9 of a spade, and we have 2 sixes, 1 of club, 1 of heart. One possible permutation will be this. We can sort by rank, but if you see in the original list, 6 of club was coming earlier than 6 of heart. But when we have this permutation, which is a sorted arrangement, 6 of heart has come before 6 of club. A stable sorting algorithm in the case of equality of key or the property upon which we are sorting preserves the relative order of elements. So if the key is equal and the element come before in the original list, it will also come before on the sorted list only. So if you are using stable sorting algorithm, it guarantees that if we will use a stable sorting algorithm, we will get this particular permutation where 6 of club will be before 6 of heart. Okay. The next parameter of classification is internal sort or external sort. When all the records that needed to be sorted are in main memory or RAM, then sort is internal sort. When all the records that are needed to be sorted are in main memory or RAM, so that sort is nothing but internal sort. If the records are on auxiliary storage like disk or tapes, quite often because it's not possible to get all of them in main memory, right? So in such sort is known as external sort. If the records are in any auxiliary storage like disk and tapes, so the type of sort is nothing but external sort. So there is one more parameter to classify, so that is recursive or non-recursive. Some sorting algorithms like quicksort, mergesort are recursive, while others like insertion, selection are non-recursive. So we will study all these parameters in detail as we will study these individual algorithms. So we have 5 classification parameters. Okay, the first one is time complexity, space complexity, the third one is stability, and fourth one is internal sort or external sort, and the fifth one and the last one is recursive or non-recursive. So don't worry, we'll study all these properties in detail as we will study these individual algorithms. So this is it for basic introduction. Thanks for watching.